you. So am I audible, sir?
Yeah, you are audible. I am audible.
Yes, sir. Yes, sir. Okay. Thank you, sir.
Please move Hall A to the stage.
कैमरा स्टार्ट कीजिए प्लीज स्टार्ट योर कैमरा.
Hello.
डॉक्टर सूद, हॉल ए का कैमरा स्टार्ट करवाइए प्लीज.
Hello, Vinod. Good morning.
Good morning, Shri. Very good morning.
Remove virtual background from Hall A, please.
Hall A, please switch on your mic.
Shall we start?
Yes.
Can I get service? Welcome everyone to the day 2 and second plenary session of this national symposium. This session is chaired by Dr. N.S. Vance, former Director of Research, PAU Ludhiana, and co-chaired by Shri Shashikant A. Sharma ji, Scientist G and Group Director VRG SAC Ahmedabad. This session will include knowledge field talks from Dr. Vinod Buthale ji, an outstanding scientist and Associate Director NRSC Hyderabad, Dr. S.P. Agarwal ji, Director NESAC Shillong, and Dr. R.P. Singh ji, Scientist G and Group Director GHCAG SAC Ahmedabad. I extend a warm welcome to the chair, co-chair, and esteemed speakers. This session will be preceded by question, answer, and discussions at the end. So we will start on geospatial applications for good governance and way forward by Dr. Vinod Buthale ji. Let me say a few words about Dr. Vinod Buthale ji. Dr. Vinod Buthale completed his bachelor's degree in engineering, electrical engineering from VNIT Nagpur and master's in electronics and communication engineering from IIT Roorkee. He is fellow of Institution of Engineers. He joined ISRO in 1986. During his 35 years of experience in ISRO, he has immensely contributed in development and application of geospatial technologies, including development of decision support systems and process automation for geospatial data processing. He has been an architect, Bhuvan, ISRS, and Maharashtra Geoportal. He spearheaded the Bhuvan program and transformed Bhuvan from a simple geoportal to the largest geospatial platform in the country for G-governance applications. Under his leadership, Bhuvan team won several accolades, including the Scotch Platinum Award, ISRO Team Excellence Award, India Geospatial Leadership Award, and ISRI Special Achievement in GIS Award. As part of the PMO's Pragati project, he facilitated review of more than 290 development and infrastructure projects by Honorable Prime Minister from 2015 onwards. He has been instrumental in providing geospatial software solutions to major national projects in remote sensing and GIS in India, and is recipient of National Geospatial Award for Excellence by ISRS and National GEOMATICS Award for Excellence by ISG. As Deputy Director, Data Processing, he led ground segment activities at NRSC and demonstrated flawless first-day imaging for 5 consecutive missions, namely ISIS, RISAT-2B, RISAT-2B R1, EOS-01, and Cartosat-3. The automated chain of data products generation has also been operationalized. Presently, he is an outstanding scientist and associate director of NRSC. Now, I request sir to grace the occasion with his vast knowledge. Over to you, sir.
Thank you very much for your kind words and the very long introduction. Thanks, Chairman, for providing me this opportunity. Thanks, Chairman and organizers. It's good to see you after a long time, and specifically in pandemic, we are able to only meet virtually. So I will be talking today in this panel session, plenary session, on the good governance specifically and the way forward. How are we going ahead with this, and what has been achieved so far? And considering that geospatial is one of the now major backbone for most of the governance applications, the topic today is very much suiting to the kind of things what we are looking for. I'm confirming. Are you able to see my presentation?
Yes, very much.
Yes, sir.
Okay, good. Thank you. The topic is geospatial applications for good governance and how can we go ahead the way forward. You can see very much on this particular slide the kind of works which are going on in the Mahatma Gandhi NREGA program on the left hand side, the data which is being facilitated through the Bhunidhi portal of NRSC, and the kind of data what we are right now putting through our common portal Bhuvan, 1 meter satellite data, which is spearheading the governance applications. But when we talk about the specifically the governance part, naturally this good governance or governance, whatever we call it, it does not come only by the decision makers. Everybody is a part and parcel of it. Every citizen is part and parcel of it. Every stakeholder is part and parcel of the good governance. So the combined efforts of all the team makes it happen. So now in terms of creating the infrastructure for governance, for the G governance, definitely we need to look at the space segment which has been created by ISRO, wherein 29 remote sensing satellites have been launched so far. And these satellites provide mainly 3 categories of the type of works. One is the resource mapping, land and water resources mainly. Secondly, cartographic mapping. And third is the environment and ocean series of satellites. So basically all these 29 satellites can be clubbed into these categories. Some are optical, some are microwave, but they basically facilitate in these kind of things. Essentially, how this space segment or space infrastructure has been utilized by the application sector is that major national missions programs have been launched over the last 2 decades, and a number of programs have been aimed at the sustainable development, basically. And among them were major national level land use land cover mapping, or the groundwater prospects mapping, the land degradation mapping or desertification. Similarly, going to the panchayat level. So all these programs, what it has done, it has created the inventory of the natural resources at the country level, and created the base which can be utilized for the sustainable development of the country. Then initially, although these efforts were saying that the decision support could be provided by the scientists, and decision makers can use it. But then later on, there was a paradigm shift that we can only enable the lowest level governance people, that is basically panchayat, and the space-based information support for decentralized planning has been started, wherein the panchayat level maps have been provided at 1:10,000 scale for various resources, along with the satellite data of 2.5 meter resolution. And then empowerment of panchayat was done so that they can do themselves planning themselves, because they know what they require. Similarly, number of good initiatives have been taken. The water resources sector, where the accelerated benefit program, and then the fisheries sector, where mapping potential fishing zones was done. So all these things, efforts, basically they were at the national level programs, wherein you can say the geospatial assets at geospatial infrastructure have been created for the applications or decision makers. Essentially, what I can say is that the space technologies, what we talk about, they have really moved from the lab to the land, and that is making a lot of great social impact on the system. Now also we are going ahead with the National Hydrology Mission and the national level information system for climate and environment. So if we look at the how it has really translated, I mean, all these databases or the repositories which have been made, they have been made available not only in the lab, but they have been made available to the public or people or ministries or the stakeholders or the states. So these maps and the applications derived from those maps have been made available through Bhuvan, and you can see this in pie chart that there are different applications. Agriculture 12 applications are there, some disaster 13, geosciences 4, or so many, like the 193 plus applications are there on board now on Bhuvan. And some of the major ones what we can see, which are really touching the lives of the people, is Mahatma Gandhi Narega program, where 40 million geotags have been received from the ground. Essentially, what it talks about, that every work which is carried out on the ground is captured by a mobile app. It is sent to the Bhuvan, and based on the progress on the Bhuvan, it is being shown. Later on, there is a payment gateway for approving the wages of the workers. So when we see that everything was stopped during the initial pandemic, even this program was providing the livelihood to the weaker sections, and that has really been the one good example of the good governance in the worst possible times of the history. Similarly, there are other programs like Housing for All, again for the weaker sections, allotment of houses, which normally transparency and accountability is required. So such kind of systems which brings space infrastructure and derived geospatial maps, as well as the information created on the ground into one single umbrella. And these kind of things can provide the transparency and accountability for the allotment of houses, which has been done initially in Telangana and then subsequently launched at the national level by ministry. Similarly, per drop more crop insurance programs, as well as idle MP, they are some of the examples. Later on, of course, all these assets, GIS assets, are very much useful for the disaster support, wherein you need to club the information, what you are available as historical information, at the same time, the near real-time information, what you are getting from the disasters. Here, like for example, the cyclone information is shown. So this cyclone information is available from the MOSDAC as well as IMD sites, apart from the GW site of the Typhoon Center. So these kind of information integration provides the damage assessment or the near real-time support for the disaster risk reduction. So these kind of applications have been launched, and subsequently we can also see that there were a number of infrastructure as well as development projects going on in the country, and it is required that these needed to be speeded up, so that it means that okay, there has to be a timeline maintained so that you can cut down the cost, as well as the projects are completed in time, so that people can take the benefit of it. So under this, there has been, of course, from 2015 onwards, there are monthly reviews by the Honorable PM, which facilitates the enhanced working of these projects. So now, in fact, 290 plus projects have been over with more than 12.3 lakh crores. So what we can see that geospatial arena or geospatial maps or the images have not remained only into the like normal sector, but it is also moving, going into sectors which are fast moving and which are really helpful to the country. You can see the examples of Bogi road bridge, which is the longest bridge in Asia, which was put on the Brahmaputra, and the progress was monitored through the geospatial means. Similarly, the further planning of this corridor, industrial corridors and all. So the development projects and the infrastructure projects, many times they need faster information. We can also see that how such kind of things can be built up in the future. But nevertheless, the historical information provides a good amount of insight. Now we see that in February, remarkable change has happened, that government has issued geospatial data guidelines. And those guidelines has facilitated many of us. Now, many of us means basically all of us are categorized in different categories. Either somebody is providing the data, somebody is doing mapping, somebody creating applications, some are the researchers who are carrying out the research work on using this data, some are the decision makers, and some are integrators. So basically we all together is the ecosystem to use this geospatial data, and these guidelines are getting into the stream of this now mainstream. And how it is going to help is that these reforms will bring a lot of clarity in terms of data dissemination. Basically, people now know what they can give, what they cannot give, and most of the things are getting into open sector. So it's becoming very easy for even people who are providing the data to have a hassle-free data movement. It will basically what it will create the impact is that it will itself will create the improvement in the data quality. Why? Because the diversity of data will be available. One is that, okay, because earlier because a lot of restrictions, data was in a very narrow band. Now the diversity of databases will be available. Then the quality of data also will increase, because more and more data flows to the user. You will get more and more feedback in terms of what are the bottlenecks in that, so that the quality can be increased. So this is one which will, in which specifically the agencies which are data producing agencies will be benefited. Secondly, now a lot of micro level data will be available because the deregulation will help in creating large scale maps also. So one is the micro level, then the large scale maps can be created, and this will really give the big boost to the mapping industry, because we see there are a lot of private industries who are working for the overseas companies, and they are getting the jobs from the overseas. But now India itself will create a lot of jobs for their micro level mapping, because high scale maps can be generated now with many of the areas, accessible areas as provided as per the guidelines. So this will provide a lot of jobs to the youngsters, and the employment will also boost the economy of the country. So this is another impact what I can see there. What is the application sector, wherein we can see there are application sectors which are untouched specifically, although there are certain level of information available in the infrastructure, the utility sector, but because of the high scale maps unavailability, these have been really in the closed containers. But now there will be a lot of innovative applications will come on the ground, and there will be a lot of challenges for the youngsters to bring new applications, and which can directly benefit to the people. Then secondly, if you also see, apart from these three sectors, that one is the agencies who are providing the data, the mapping sector and the application sector, the researchers will be greatly benefited, because they will be benefited because data availability is there, more and more data will be available. So they can, that opens up the new vistas for the areas, research areas, and it will also increase the turnaround time and create the better accuracy information with the due consideration of the varied amount of data in models. So, and once this research happens, naturally each other sectors get benefited with the outcome of this. And finally, the administrators and decision makers will be benefited, because all this will facilitate their better decision making. And finally, the integrators, because now the people who are integrating the data, they were earlier using different type of databases or the base maps. So now it will create bigger harmony, because each one will have some common frameworks to work. So this is one big change what we can see which will happen. Now, naturally, when we think of such a change, and earlier so much work has been done, so much applications have been made, then now lately these new reforms have come. So naturally, we need to go ahead now. I mean, what now people don't need now stale solutions. They expect that there should be a near real-time solutions or solutions to the real-time problems. Then we need to model the complex world, because world is quite complex. And if we really want the solutions of near real-time or real-time, we need to model the complex world. And there are now technologies by which we can do it. I'll talk about this. And third is that add the dynamics of it, because many times we are not able to add the more and more dynamic information, which is actually dynamics happening on the ground, cannot be built into the system. So without that dynamism, your decisions becomes obsolete sometimes. So what we need to do is that we need to be solution oriented, and solutions need to be action oriented. And these solutions and actions have to have basic inputs from the technology things. So with this, we can really be able to provide the advisory services on one hand and recommendation services on other hand. Then with bringing this into the picture, we also need to target the newer technologies. We can say, I mean, there are multiple things which are available, and everybody is working with the artificial intelligence and machine learning problems and techniques they are using to solve the problems of real world. But additionally, these kind of thing has to go to the not only in the government sector, but academy and industry has to work together with the government, so that the larger level problems of food security or the water security or the disasters or the land record dynamics can be really solved. And that cannot be solved with the just kind of satellite data or the geospatial maps which are created. We need crowdsourcing mechanism. We need to bring Internet of Things and get the micro level input from the ground. And public sourcing has to be done. Now, when we do take off the public sourcing or the crowdsourcing, basically you are trying to get the inputs from the ground, but these inputs need to be validated. So now manual validation of such inputs is a very, very difficult task, because it's a very large task to go ahead with the checking, and manual intervention is not at all possible. So there has to be a truth discovery models. It has already been worked on by some of the people, and I think the research is in good stage where truth discovery can happen automatically, so that there could be some level of validation at some conference level for using this publicly sourced data. So then the kind of maps what we are talking about earlier, they were coming in the map with a kind of semi-automated mapping, but now automated mapping needs to be done with the AI/ML technology, where thematic maps need to be created in the rapid pace. You can't wait for the year or so for the thematic map to come. So definitely these are the initiatives that needs to be taken up. Then quality has to be automated, and validation has to happen, because ultimately that will derive the decisions making, and what are the quality of decisions will be depends on the quality of the input. So these are the things which need to come up. And next, where a bigger technology which has been used for many other sectors is also coming in the geospatial applications, and that is blockchain. Blockchain is not a new, it's a very old concept, but with very recently this Bitcoin time, it has come into the picture, and people have really now taken it forward. So essentially it talks about the immutable trustless registry of entries. Then second, I mean, key points, if we really see, it's immutable. Secondly, it is open, it's available on the open distributed network. Thirdly, it is more resilient and creates transparency and accountability. Now, how this blockchain, now two major problems which we will face is that one is that the public good data, because there will be a lot of data with this, all these reforms, this data need to be made available. But at the same time, you need to secure the data in a different way. It's not that holding the data from the people, but the data quality has to be maintained. So you must ensure that the data integrity is maintained properly. It is not only the sharing the data, but data integrity has to be maintained. So blockchain is one technology which will actually split the entire data sets into the small blocks, and these blocks are interconnected, and there are hash code stores. Hash code of the previous block is stored in the next block. So if any content are modified in any particular block, and the integrity of data is at the stake, then blockchain will definitely identify it and put up the problem, and that could be further resolved. resolved that, okay, I mean, either the data will not be given or data need to be corrected. So such a kind of usage of blockchain, ISVJ, and usage specifically for the public good data. And it is being already used in the sensitive information, wherever, like, for example, land ownership and all. Blockchain is being used or in other applications elsewhere, wherein we can know that the information is not tampered, and if it is tampered, then it is known that it is tampered. So this is one technology which is really going to help us. Secondly, digital twin. Everybody talks. It's not that new topic now. Also, recently there are some platforms launched in India also by some of the private players. What we need here is that basically I was talking about dynamism, that every department's workflow need to be monitored in a way that entire workflow is captured, and it is not only the model of the 3D creation of 3D model of a real world as a mechanism, but it needs to be added with all the behavior that it has. It has to be brought, all the real-time data which is pertaining to that has to be added. For example, anything which is happening for a store, if you have a warehouse and that warehouse has to be monitored with some specific parameters of their humidity or the temperature. So those parameters need to flow into the system. So practically you are trying to build a real system into the GIS domain. It is not only the GIS work alone, but GIS plus IoT plus many things will combine together, and ultimately this technology will bring up how it will actually improve is that from a 2D you will actually go to the 4D, because it will be also be time varying, and then you will be able to know the real time parameters, so that the decisions could be more viable. So this is one thing which is coming up now. To facilitate all that, I was talking about the geo-reference GIS data, which is being powered. Now satellite data also is being distributed from the one portal. Bhuvan, you have seen that Bhuniti is another portal of NRSC, which is providing now satellite data. Earlier it was like user order processing system. Now it is called Bhuniti. That is ISRO's Earth Observation Data Hub. You get all the data sets which have been mentioned here through that. And this is as per the policy. Whichever data is open right now, you will get free of cost. But whichever is as per the charge, it will be charged, or it will be, I mean, you will be asked to put in the card and do the payment. But otherwise, whichever is policy. Suppose now, subsequent also we are hearing that more of openness is coming in satellite data. Also, based on that policies, this will be further regulated. But today you can get multiple options of data. You can download the data, you can use the library, or you can use the API. And it is now it's a regional hub. Basically, for any area of interest, you get the data of three major segments. One is the Indian remote sensing satellite, second is Sentinel satellites, and third is the Landsat satellite. So with amalgamation of all the three satellite data coming from Bhuniti will be a great booster for the people who are working on the projects or the researchers basically. And it has got the, as a global portals, what you see, typical all the search options or the download options are available here. So I'm sure that you can visit Bhuniti and see how it is useful. You can also give feedback, and ultimately we move together for the better future. So as I'm mentioning, this good governance can't be achieved through a social empowerment. So we have to see that the citizens are educated, the decision makers are educated, the system is made in such a way that everybody cooperates for the best governance. Thank you so much.
Thank you, sir, for enlightening us with ocean of your knowledge. Now I invite Dr. S.P. Agarwal to the stage for his words on space technology and applications for development of Northeastern region. Dr. Sivaprasad Agarwal is well known in the research fraternity of water resources management and remote sensing. A doctoral research scholar from the prestigious Indian Agriculture Research Institute, New Delhi, and a postdoctoral fellow from ITC Netherlands in the field of hydrological modeling.
Dr. Agarwal has contributed enormously in various subdomains of water resources and hydrology, such as hydrological modeling, irrigation water management, soil erosion assessment, snow, ice, and glacier melt studies, flood mapping, monitoring and flood early warning systems, cryosphere research in Antarctica and Arctic region. During his illustrious career spanning over 25 years of as a scientist and engineer in ISRO, Department of Space, being posted at the prestigious Indian Institute of Remote Sensing, Dehradun. He has over 150 research publications in peer-reviewed national and international journals, along with authored books and chapters. Apart from 5 PhDs, Dr. Agarwal has guided a large number of MTech, MSc, and PG diploma theses. Apart from research and academics, his contribution in administrative and organizational roles has also been appreciated. As program coordinator of the UN-affiliated Center for Space Science and Technology Education in Asia and Pacific during 2016 to 2021 period, Dr. Agarwal played a pivotal role in strengthening regional and international cooperation in capacity building in space science technology and applications in the Asia-Pacific region. Currently, as the director of the Northeastern Space Application Center of Department of Space, Shillong, Dr. Agarwal has taken important initiatives towards effective implementation of space technology applications for various governance initiatives such as disaster management modernization, land record management at the state level, development of agriculture and water resources, ICT-based applications for ease of governance, etc. He received several awards and honors, including the Institution of Engineers of India, Uttarakhand State, conferring him with the Eminent Engineers Award for year 2014 for his outstanding contributions in the field. He received the President Appreciation Medal by the Indian Society of Remote Sensing for year 2016 and the prestigious National Geospatial Award for Excellence by ISRS for year 2018. He is a fellow of the Institutions of Engineers and the Indian Association of Hydrologists. Even a complete day is not sufficient to discuss his contributions and achievements. Without taking any much time, I would like to request sir to grace the stage. Over to you, sir.
Thank you, madam. I hope I am audible as well as my slides are visible.
Yes, sir. Yes, sir. Welcome.
Thank you. So good morning to each and everyone. Indeed, it is my honor and privilege to talking to you on the space technology applications for development of Northeast region. So why an NER is so important for our country? You know, there are 8 states. You know, this is Sikkim, Arunachal Pradesh, Assam, then Meghalaya, then Tripura, then Mizoram, then Manipur, Nagaland, and of course, Arunachal Pradesh. Also, you know that it is surrounded by many countries also. So international border is also very important for us. Not only that, you know that it has only 8% land area of the country, but it has 30% water resources of the country. Its hydropower potential is 44% if you compare for the entire country. You know that currently in Northeast region, the total hydropower potential is 66,000 megawatts. It has 24% of the forest area of the country. And most importantly, it is the second biggest biodiversity hotspot in the world. So you can imagine the importance of Northeast region for our country. And not only that, development of the region is the main priority for our government. So Northeast Space Applications Center was established in 2000, September 2000, and our activities are mainly belongs to 4 verticals: remote sensing and GIS application, disaster risk reduction, satellite and atmospheric space and atmospheric sciences, and satellite communication. Now, in remote sensing application, we are working in the field of agriculture and allied sectors, forestry and ecology, soils, water resources, urban and regional planning, geosciences. In disaster risk reduction, we are working in flood early warning system, Japanese fever, crop damage, weather forecast, lightning, thunderstorm, etc. In space and atmospheric sciences, we are working in the field of weather forecasting, thunderstorm, aerosol radiative forcing, boundary layer problems, etc. In satellite communication application, because northeast region, there is many places where we cannot reach. So reaching to unreach is the basic concept of satellite communication application. And we are doing this like tele-education, telemedicine, and emergency communication during disaster, then location-based services with the Navik and Gagan, etc. So far, we have completed and in progress 400 plus projects all over 8 states. Ongoing projects, currently we are having 174 projects for all the 8 states. We have signed MOU almost all the state government, various departments of 8 states. Not only that, like ISC, IIT, Guwahati, Delhi University, NITs, all these places we have MOU. We have more than 500 plus research publication, and we have received 11 national level awards. And we have a very state-of-the-art outreach facility. What the technologies which we are using. Now, this is the very famous slide you must have seen many times, but nevertheless, to maintain the continuity, I would like to tell you that we are using our Indian satellites for land and water resources like ResourceSat 2, 2A, ReSat 1, for hydrolation mapping and DEM, Cartosat 2, Cartosat 1, and then OceanSat 2 and Saral for altimetry, and for weather like INSAT 3D and 3DR. Not only that, for satellite communication, we are using various satellites. We are taking help of various satellites, but currently we are using GSAT 18. And for Gagan, for navigation, Navik, of course, is a new one, but nevertheless, Gagan dongle we are using, and we are utilizing this technology for the large scale mapping of the land records. Other than that, NESAC is having state-of-the-art facility, UAV facility. We have different kind of UAVs for the various purpose. We have a quadcopter. We have hexacopter also. There are 6 wings. You can see here. We have that hybrid UAV also. Now, somewhere this fixed wing UAV is very good because it flies very fast and it covers big area in less time. But sometimes it is necessary that you should have a hexacopter or quadcopter kind of thing. So this UAV is such that either it can be fixed wing and you can change it while flying only to the quadcopter also. So this UAV also we are having, and we are flying, and then we are having different sensors like multispectral sensor, then hyperspectral sensor, then thermal sensor. So these sensors we are putting in this UAV. What is another important thing is our engineers can modify these UAV as per the payload and requirement. Recently, we have done one experiment. There was a requirement of government of Assam that they want to deliver the medicine to particular place. So we have done this experiment, and the medicine was successfully delivered. Now, other than that, there is a large number of field instruments. You know that Northeast is highly vulnerable for different disasters, especially floods. For that, we have to monitor the rainfall or weather. So we have a Doppler weather radar at Cherrapunji. You know the Cherrapunji and Mausimram, they are the highest, wettest place on the earth. So their average annual rainfall is 11,000 plus millimeter. So for that, we have to monitor the total monsoon system, total, cloud system also. So we have a Doppler weather radar installed at Cherrapunji. Not only that, there are many automatic weather stations across the Northeast region. Then spectroradiometers for field experimentations. Then DGPS, of course, we have. Another very important, like for atmospheric studies, trace gas analyzer we have. Then we are launching this meteorological balloons with Pisaroti radio Sunday, so we can have the vertical profile of atmosphere. Then we have Gagan dongles. You know that recently one web app which was developed by NESAC for Tripura government. This was inaugurated. That is a Vana Adhikar. So it's a right of forest to the people. So Tripura Vana Adhikar app. Now it was launched by the Union Minister of Rural Development and Panchayati Raj, Sri Giriraj C. Now what these people are they are doing, that we have developed the app, and they have the Gagan dongle. And what they are doing, that they are going to a particular field. Suppose the field belongs to some farmer or some person. Like you know that here forestry is a social forestry. So forestry belongs to a person, but they don't have any, they don't have information. So they can map it using our app and this Gagan dongle. Why we are using Gagan dongle? Because it gives the better accuracy than the normal GPS phones. So we are having an accelerometer also. So many, this is few numbers only I have given. There are many more instruments are available. So you can imagine that combination of satellite technology is for example, remote sensing satellites, then satellite communication technology using the satellites, then that Gagan technology, not and the field in, data, and then the UAV technology. So we are combining all these technology together to come to a solution. So now I am coming to the solutions. So first I will start with the agriculture. So remote sensing application in agriculture. So in this region, we are working in the crop acreage and production estimation, soil resource and land capability mapping, crop damage assessment, agricultural drought assessment. We are using UAV for precision agriculture, sericulture development, crop system analysis and crop intensification, site suitability analysis for crop area expansions. So these are the area in the field of agriculture we are working. I'm going to give you a few examples. Now look at this. Of course, we are doing for entire Northeast region, but this is one example of Meghalaya state, winter rice acreage estimation in Meghalaya. So all districts, East Kasil, West Kasil, all districts, what is the winter rice acreage? So we have estimated using the our satellite imageries. Now, this is very ambitious project of Government of India. You know the Chaman. This is, basically MNCC is responsible, but we are responsible for all Northeast region states. Now, what is the idea of this? That we are, finding out the site suitability for the expansion of the horticulture crop. You know that here in Northeast region, people are very poor. Now, if you want to double the income of farmer, there is a very basic concept of our government of India, Prime Minister Modi ji. So in Northeast India also we are doing it. So for that, what we can do? The land is limited. So is there any area where we can further, find a suitable site for this horticulture crops? And we are doing it rigorously. So we have already completed 24 districts of Northeast region in phase 1 and phase 2. And 24 district and state user departments are using it. And now we are planning for all the states. In fact, recently we had a meeting with government of Assam and all their horticulture directors from different districts. They have a discussion with our team, including me, and we could able to detect what are the different horticulture crops they can grow in an area where currently there is no crop. So this is very important project, and of course satellite data is very important for identification of suitable site for expansion of the horticulture crops. Now next is the application UAV. So this is one example. Like suppose if it is a small area in Northeast region, either you have a hilly area or is a small agriculture land holding of farmer. So based on the requirement, what we can do, we fly over that area, and then we can have a crop damage assessment. You can look into this image very nicely. It is visible. Now, in fact, with UAV, individual plots are visible, and you can find out how much crop is damaged and in which plot, how much area is damaged. This is very important. And another very important thing about UAV is in North region, like Meghalaya, 6-month rainfall is there. Okay. And always there is a cloud. So getting satellite data is very difficult, especially during the crop season. So UAV plays a very important role, and that is the reason why our center is mainly emphasizing, other than the satellite technology, UAV technologies. And it's a highly in demand also nowadays. Now, other thing, space technology application for sericulture development. Now, there is in this Northeast region, a lot of scope is there for, sericulture. So potential area mapping of 178 priority districts from 25 states, of course, but in Northeast state, what we are doing, Malwari, the silk, Muga, Eri, and Tussar silk. We are working potential site suitability of the area. Then early warning of selected Muga silkworm decision-based various landscape parameter crucial for disease incidence are being evaluated using the UAV remote sensing. because it's a small area, so we have to go for UAV only. Okay, then geotagging of assets created under the Central Silk Board funded projects. So this is another very important project that Silk Board, they have developed, they have given a lot of fund for their project. So we have to monitor using the UAV and remote sensing. Now let us come to the forestry and ecology. So as I told you, we have 24% forest of the country. So mapping, monitoring, and modeling of the forest is very important for this region. So we have prepared forest working plan for we have provided the input for Assam, Arunachal Pradesh, Mizoram, and Meghalaya, and we are working for others also. Forest fire and burned area assessment we are doing for entire Northeast region. Above ground biomass estimation for entire Northeast region. Shifting cultivation area mapping of entire Northeast region. In fact, this project was given and it is completed now. I'm going to show you some results on it. Bamboo resource mapping, vegetation phenology analysis, forest cover change monitoring, wildlife habitat mapping, land cover dynamics, change detection. Now, this is one example of Mizoram mapping of shifting cultivation. In fact, we have covered 7 states of this Northeast region. Out of that, I'm showing you one example of Mizoram. Mizoram is here, and this is one example. So this is, area I'm zooming in, then further zoomed in to this area. Now let us see the satellite imagery. So this is the imagery of 2017. And I would like to tell you, look at this area. And you see, he's all red, so it's good forest in 17. But what happened to 18? You can see cyan color has come up, means forest is cut. So it means the forest area is converted into the area, cultivation. So that way we could able to map entire, this area, entire Northeast region. And this project is completed. So this is different years, and this is finally mapped and given to the departments. Now, mapping of bamboo resources for the state of Meghalaya. So mapping of bamboo resources of NER region, we have taken up in the phased manner. The detailed mapping of bamboo growing area of Mizoram, selected district of Assam, already completed. Now, analysis of forest cover change dynamics of Northeast region also we are doing. Now, water resources. This is very important aspect of this region. So, flood early warning system, we are doing this flood early warning using the satellite technology, space-based input coupled with the weather and the flood models. And we are doing this since 2009. And in 2021, I can tell you that our accuracy was 80%. So this is very good information we are providing to the State Disaster Management Authority of Northeast region. So we are doing currently for Assam, but now we are converting to all the states. Then we are doing another work, flood water diversion in Dhemaji district of Assam. Then district level river atlas for Assam is completed. For other states, we are working. Identification of stable island in Brahmaputra main channel. Assam police has given us this important task, and we have completed this project. And recently we have presented before the DGP of Assam. Then hydropower projects through NIPCO, Northeast Electric Power Corporation. We are working with them and we are doing the projects. Then feasibility study on the construction of major bridges over river Brahmaputra. Already one example is shown by our Sri Vinod Buthaleji, that how NRSC is helping them. And from here, some projects we are doing from NESEC. Then assessment of utilization of irrigation potential created for 4 irrigation projects we are doing. This is NEC funded project. Now, this is one example, like there are 39 tributaries. Model is established. Then based on the WRF output, we are having rainfall with the lead time of 24 hours and 48 hours. Model is set up, and finally hydrographs are generated.
Start again.
So finally, the users want this type of map because they don't understand what is hydrograph. They want, with respect to the time, if a big event storms occurs, then how that water that is flowing to the urban area. So this type of maps based on the requirements are developed. Now, this is another very important project, that suppose a rainfall occurs and the flood event is going to happen. So if I divert that high amount water to an area which is either wetland, already wetland, or excavated, then how much flow will be reduced, so that the peak flow will be reduced and people will be affected less. So we have done analysis for Dhemaji district, and you know that total 29 wetlands have been identified. The capacity currently is 35 million cubic meters, so it can store water. This much water they can store. But if we can excavate these wetlands by 2 meter, then the capacity from 35 million cubic meter, it will increase to 60 million cubic meter. And suppose we will provide a embankment all around this wetland, then the capacity will increase by 84 million cubic meter. So this is very important project which is taken up, and I hope this will reduce. It cannot stop the flood, but however, it can reduce the flood peak, and which is very, very important for survival of the people. Now, geosciences, we are doing a lot of work, like, input for planning and restoration of affected area, coal mining, then preparation of lineament map, Pradhan Mantri Gramin Sadak Yojana, then landslide inventory, then route alignment of construction of road in some area. Now, look at this image. If you see here, what you are seeing, some spots, black spots, they are basically the coal dump images. So in this area, so when coal dump images are there, area is there, it means there are coal mining. So this is actual from satellite imagery, and you can see here, this is real field photographs. So this we are mapping for entire Meghalaya, because in Meghalaya, there are a lot of issue related to the mining, and this government of Meghalaya has given us the project to kindly map the mining where even people cannot reach, where only those people who knows this area. So with the remote sensing, a UAV, we are doing this work. Another thing is the landslide. So we have prepared the landslide susceptibility map, and you can NRSC, we are also mapping wherever landslide occurs. So we are mapping the landslide vertical area. So this is a fresh landslide is visible here, while here it is an old landslide is visible. Now, urban and regional planning, like Amrit project, we are doing remote sensing GIS-based input for vertical hazard vulnerability of the rural area. Then village level mapping we are doing. Then Shillong City disaster management plan we have already almost completed and given presentation to the secretary. Now, this is one example that Atal Mission for Rejuvenation and Urban Transformation, Amrit. So objective is creation of geo database for Shillong planning area. So preparation of GIS database generation, base information, urban land use, other using remote sensing GIS technology. It is at 1:4,000 scale. Then GIS based master plan of Shillong. So this we have almost completed. In fact, first draft already presented before the Secretary of Ministry of Urban Development of Meghalaya. So we have used the Cartoset data, then ancillary data, socioeconomic survey, transport survey, and we have completed this project. Almost completed. Now, finally, in fact, we have met almost all the user department. I would like to emphasize here, whatever work we are doing, we are directly involving the user departments. So for city planning, what are the user department? Not only the urban department, traffic department is also important. Drinking water supply department is also important. Disaster management department is also important. So we are interacting with all these people, and we are taking their suggestion while finalizing our plan. Now, this is another one, rural development plan for model village. And we have proposed one village here, you can see in 3D, and in Musai, Kibutu and Kaho villages. And you can see some plans we have given. And these type of plans, I think this is very ambitious project. And we hope that if we complete and if it is implemented, this is for Arunachal Pradesh. If it is implemented, this is going to be a model village for entire country. So UAV facilities already I have discussed. So UAV remote sensing, for example, I will give you only one example, but list is there. Estimation of earthwork for extension of Shillong Airport, embankment survey and monitoring in Assam. Because embankment survey, what is important? With remote sensing data, we cannot see is there any damage in the embankment. And what happens, suddenly the river flow at high level, then suddenly this embankment breach takes place. So government of Assam has given us this project that kindly do the embankment survey through UAV. So all the weak areas we are doing this survey, and we could able to find out the weak areas of embankment, and immediately we are telling to the people that concerned government departments, and now it's up to them that they have to repair that embankment. So this we have done through UAV. Okay, then survey and mapping of community reserve forest, wetland survey, construction site monitoring. This I will come little later. community reserve forest boundary, volume estimation of khairwood, crop health and yield monitoring, village resource mapping, disaster management support. So you see the UAV nowadays in Northeast region, I can tell you that it is complementing the satellite data. Satellite data is having, it has a lot of advantage, but it is having certain limitations. So our UAV technology is complementing that and fulfilling that limitation. So combination, I always used to tell to Northeast departments, the combination of satellite technology and the UAV, it is really a big solution for many problems in this region. This is one example. You know that Shillong Airport, it is very close to our NESEC. It is only 9 kilometers from here by road journey. Okay, and there was a problem when the plane was landing. It's a small airport where only small plane come, but there was a request from PWD. So that airport authority has contacted PWD and PWD has contacted us that we are preparing now DPR to how to increase the runway and how to avoid the hindering of landing of the plane. So they have given us that kindly fly the UAV and find out that detailed DEM of that area and cut fill ratio so that we can remove the that hill or part of the hill so that there will be a proper landing. So these different maps were generated and finally this area you can see hill is there and finally cut fill ratio is analyzed and given to the PWD. Now it has given to PWD. Now it's up to them how to utilize this for that airport with the help of airport authority. They are sure that landing process is going to be very easy after this project. Now, this is another very important aspect already Dr. Binod Botale has discussed in detail about it, but nevertheless, I will focus on the Northeast region. NESEC is responsible for doing all these geo-based data portal and governance, IT and governance services to the Northeast region. So we have a portal, Northeastern Spatial Data Repository. Now this is funded by NEC, a Ministry of Donor. Total now 1,125 data set with 25 plus applications. It is available here. It is very soon. It is going to launch by some senior authority from Government of India. Then geotagging and monitoring of NEC, Ministry of Donor funded projects. Now 556 project with 1,553 project sites we have taken up. Now I will show you one example like that 556 projects. So what are these projects? These projects are, in Northeast, government is giving a lot of funds for development, road development, infrastructure like railway development, road development, bus stands, airports, hospitals. They are giving a lot many funds and they are having lot projects. But government want that there should be a portal and with the help of remote sensing a UAV, we should monitor these projects whether they are following the timeline or not. So we are doing it. I will show you one example. But before that, so like integrated WebGIS platform for dissemination of real-time early warning system, development of geotourism dashboard, fever tracker application for ICMR, then DSS for monitoring and management of African swine fever. In Assam and Mizoram, we are having this problem. Then demarcation of revenue patta using mobile app for Tripura. So already I have discussed about it. Now let us come to the project. Now this is one project. This is the construction of the river bridge. So Silchar, Assam. So funded by Ministry of Donor. Now what they have asked us to monitor the construction. I have shown you only that, some picture, but we have monitored almost monthly or bi-monthly. You can see here there is only one bridge. And now 2017, the construction started. You can see here. Now compare this image to this image. So construction work started. Now 2018, now you can see the bridge has come up. Now, so within 1 year only, or less than 9 months only, you see the bridge is completed. At least initial structure is completed. So this type of monitoring we are doing, how much time a project is taking. So suppose we are used UAV. So every month we can go there and we can monitor it. So you can see this. This is 2020 completed, and this is a field photograph. So such type of monitoring we are doing for 500 projects, 500 plus project for entire Northeast region, and this is available on our dashboard. Then space and atmospheric science. So I told you we have a DW.
Can you finish in 2 minutes, 2-3 minutes?
Yes, I'm finishing. Thank you. And then it was launched by our Honorable Prime Minister, Sri Narendra Modi ji. So you can see the picture here. But we are doing many other things also, aerosol characterization and other things. Now, SATCOM projects, as I told you, tele-education, there are 7 hubs and 325 SITs are there, satellite integrated terminals. Last year, we have completed that, this facility is used, and total 50,000 plus students were trained using tele-education. Telemedicine, we are having 20 nodes for Army 17, Civil 3. Then communication support, DMSP, we are providing, location-based service we are providing, and of course, Gagan and Navig we are using. Then already I have already talked about disaster risk reduction, crop damage, earthquake precursor, thunderstorm and lightning, UAV facility for disaster management. And then we are also doing a lot of capacity building for user departments, and one international program also we have done. So this is all from my side. Thank you very much.
Thank you, sir, for enlightening us about development of space. Thank you, sir, for enlightening us about development of space and IT technology in Northeastern region. Now, I invite Dr. R.P. Singh to the dais for his words on advancement in satellite technology. Dr. R.P. Singh received the MSc degree in physics from IIT New Delhi, India, and PhD degree from Banaras Hindu University, Varanasi, India. He is currently working as Scientist G and Group Director in Space Application Center, Ahmedabad, and leading team for hydrological applications.
Unmute, ma'am, please. Please unmute. Holly, unmute, please.
Are we audible from Hall A?
Now you are audible.
You are audible.
Okay.
You are earlier also audible.
Okay, now I again formally invite Dr. R.P. Singh to the dais for his words on advancement in satellite hydrology. He received the MSc degree in physics from IIT New Delhi, India, and PhD degree from Banaras Hindu University, Varanasi. He is currently working as Scientist G and Group Director in Space Application Center, ISRO, Ahmedabad, and he is leading team of scientists for hydrological applications. He is a principal investigator of thermal infrared imaging spectrometer instrument on board India's Mars orbiter mission. His current research interests include space-based hydrological modeling and thermal infrared sensing of Martian surface and atmosphere. Dr. Singh is Chief Editor of Journal of Geomatics and recipient of Indian Society of Remote Sensing Professor P.R. Paisharati Memorial Award. I would like to invite sir to grace the stage. Over to you, sir.
Sir, please unmute yourself. Unmute yourself, sir.
I'm audible now?
Yes, sir.
Hello?
Right.
Yes. Okay. And my slides are visible? Let me put on the full screen mode. Whether my slides are visible?
Yes,
Hello?
Yes, sir. Yes, sir. Please start.
Okay. Thank you. Thank you for nice words. And respected Chair, Dr. N.S. Bans, and Shashikant Sharma ji, Dr. Buthale, Dr. S.P. Agrawal, and good morning to everybody. Today, the topic of my presentation is the advancement in satellite hydrology. In fact, we heard two beautiful lectures, very informative lectures from Dr. Buthale and Dr. S.P. Agrawal ji, and they in fact covered most of the gamuts of Earth observations and in the country and the recent trends in those directions, how they are being helpful in our country. So I have advantage of having a lot of background knowledge to you. So I'll only focus upon the new developments in hydrology, which is a more focused area of EU applications. And As you know, the hydrology is important because water anyway is required for the existence of life, and even most of the civilization depend upon it. It is very well known about this, and that is why we go on exploring not only Earth but in many planetary systems. Hydrology, by definition, is a science that deals with the occurrence, distribution, movement, and properties of water on Earth, and obviously its relationship with the environment. And it is a basically enduring subject in my understanding, where the instruments and scientific principle has to be involved and developed to solve the water-related problem in society. So, and satellite becomes the very, very important tool or technology in that sense when we are trying to deal the larger society or the larger picture of the country or the globe as such. If we talk about satellite hydrology in India and history, start with the vision of Dr. Sarabhai, where he requested, I got this letter of Dr. Sarabhai to Indira Gandhi ji in 1969, where he requested to have a presentation to the Prime Minister of that time, 1969, that how the satellites in future are going to change the governance that Dr. Bathali was talking about. It was a vision in 60s. And if you can see in this letter, the hydrology section, was presented by Dr. Professor K.R. Ramanathan, who was the earlier former director of physical research later. And there he promised in 1969 that river levels, flood forecasting, water resources on surface and underground, those would be the potential areas which would be solved once satellites come. And that's where the beginning of ISRO takes place. And if you see from that point onwards till today, if you go to the Vedas portal, go to MOSDEC portal, go to Bhuvan portal of NISAC, this NRSC, and in fact, what Dr. Agarwal was talking about in NISAC, you'll see the vision in 1969 and the current, the level of the technology available is enormous. In my opinion, this first phase of the vision, is completes, because now whatever was the promise on that time, you can find, particularly go to Veda's portal where we work on that line with Dr. Sashikant Sharma. You'll find, continuous measurements of satellite on water level. You can find daily real-time measurement of discharges in the river for whole country through the model, and many, many, many products. So I consider that to be the one phase of vision being completed or maturing to some extent. But then, the science continues, and today the lecture will discuss how we are progressing on that line. Evolution, if I talk about for the students, those who are new to this field, obviously we started very humbly by visual interpretations, 1970s or partly 80s. Then it was a regional assessment of watershed wetland using digital techniques also from TM1 when our satellites took place, ISG3, AVIS. Then the third stage was the retrieval of this parameter through mathematically inverting or modeling, where we use SAR models. Currently, we are using GRACE. And then another very important development which is taking place in most of the institution and most of the team which deal in, including the academic setup, is to have a national hydrological modeling. Already NRSA has this. We are also working on that line, because satellites obviously cannot provide all solutions. They only becomes more viable when they are ingested into a model, because model gives you continuous outputs of various parameters. And there is a long way ahead to move, because at moment also satellites are limited in terms of the revisit and resolutions. We all very much know, and there are many, many new technologies are emerging up, so in future, obviously, there will be constellation, machine learning, many, many things. So I'll just take today's half an hour with you to go to just discuss how we evolve with the time and how we are moving ahead in future. What are the new ways or the new technologies in this field? I got this particular one proceeding of seminar in 1977 in SAT. It was held on remote sensing of hydrology in those times, 97. In my opinion, they were the first set of seminar. Today we are discussing this seminar. In fact, the starting of such satellite hydrology took place in 1977 in SAC, where most of the exports from the country, that time SAC or ISRO was evolving from IMD, CWC, the Geological Survey of India. They all sat together and they chalk out the plan, discuss the current technologies at the time. I was going through that. I considered them to be a reference line from where this team or the group started, this light hydrology. And if you find into that proceeding, you'll find majority of papers were more on a visual analysis of drainage network, geomorphology, and fluvial geometries, and mapping drainage channels. Because that time, I mean, Landsat already has come up, but then, I mean, digital things were just emerging out. Computers were not that fast. So things were of that level. And today, if you talk, if you see your water, yesterday I was sitting in that particular smart water session, and you see that there's a sea change in the type of work being done that time and now, and that's how the learning is. One I wanted to share with you is that even that time in 1970s, this Bhaskara satellite was launched in 1979, and a lot of ground experimentation took place, and that became the building block of those area. Professor O.P.N. Kalla and many other scientists of that time were developing in-house those technology, conducting experiment in Gujarat University in 19 gigahertz. And this is some example where they have given in this proceeding also. I was excited to see that such a good development as such a humble beginning and questful beginning from some of the people of that era who were knowing this technology, that where it is going to go. And that humble technology now has come into the form like currently this, you see SCATSat-1, which is one of the very good satellite. There you can find, we are able to see in details, see the pictures of that time when there was very, very coarse resolution, just preliminary observation of brightness, temperature, variations for India taken from Bhaskara 1979, and current knowledge of i-GEOMATICS, where every day we can see the floods or the wet places in country, and you can assess those regions. So things has changed a lot. I wanted to show you globally, this map mission has changed the way hydrology is done. Yeah, soil moisture was supposed to be very, complex job, but now with this mission, daily you can get the soil moisture map over the whole globe. So that has been the change in the technological development. There are many more development going to come into this line. As far as our country is concerned, we started in 1979, and I said in Bhaskara satellite, which was repeatedly, repeat satellite was sent in 1981 also, Bhaskara 1 and Bhaskara 2. And then it was a journey onwards. Dr. Bothale was talking. We had 29 satellites on the line, which started from 1 kilometer resolution. Now we have a sub-meter resolution satellite. We started from few channel multispectral systems. Now we have many channel multispectral systems. In between 1982, the INSET series took place. I'm not going in details of how they go, but there's a big journey where ISRO took a lot of development in technology, and there that leads into the application program. In summary, I would say that in this last 2 to 3 decades, 4 to decades, the mapping of wetland, flood mapping, drought assessment, groundwater prospect mapping, water quality to some extent, snow melt, storage capacity of reservoir, irrigation water management, national water plan. These are the many important activities which were done with the user departments. Somewhere they are case studies, somewhere they are operational activities were done, or country level things were done. And in my opinion, this technology has matured to some extent now and been useful, as what told by my earlier speakers. But the science challenges remains. The demands continue to improve with the time, and in my opinion, the future demands lie detection of shallow aquifers. Still, we do not know what is buried inside our ground. So technology has to further go into it. This ground, the penetration radars has to go on airborne, has to go on satellite, so that we can know our aquifers. We do not know much about how much fresh water discharge go from the seabed itself. What we know from how much it goes from the rivers into ocean. But there are many groundwater discharges that still has to be known. There are many buried channels, pre-glacial valleys, lake hydrology. Sometime you might be knowing the extreme events take place and suddenly Hyderabad, Chennai, or any big city like Mumbai get too much flooded. Huge amount of water comes there. How does it come? What happens to them? There are some of the challenges we have to note it down. I mean, work on that. Transpiration for forest is still a very, I would say, less known subject, not much considered into the hydrological because lack of observation, modeling and forecasting remains the challenge. Of course, future AI, and so these are the few things what we have achieved, and obviously we have to work upon many of things. And in my opinion, in future it's going to happen. Technology are progressing in that line. Just to start, I mean, just to share some of my experiences in this line, what we are doing at SAC, I'd like to just discuss the school book kind of hydrology to the participant, particularly students, those who are listening. That dealing hydrology means dealing the rain, precipitation in terms of snow, and then how much the surface runoff took place. Then part of it get evaporated. Some of them get transpirated also, and that we call evapotranspiration because there is a vegetation that make your surface wet. You call soil moisture. It looks very simple, but soil moisture governs a lot in form of agricultural productivities and climate models and many. Even with the forecastings, then when the water accumulated becomes lake storage, then it forms the stream flow. Obviously, some of them percolates, infiltrate in the ground, and then they become groundwater. These are the various dimensions we have to discuss, or we have to deal this thing. Satellites are very good in some of them. Still, some technologies are emerging. I'll just take few parameters and share how we are working and how these things are improved. As I said, hydrology is forced by meteorology. The rain, ultimately rain is the basic input from where hydrology, if you know the rain, then only you can do any hydrological modeling. And as far as the rain is concerned, from 1960, the Tyros launched in 60s. This work started in 60s and 70s, quite early. But that time, the satellites were not that resolved or that, I would say, sophisticated what they are now. But I wanted to show you that our country, a lot of people, particularly IMD, they were working in this time frame also, 70s time frame. The left image shows a picture where they were analyzing that how much the temperature of the cloud and their coolness result into rainfall, how this track the cyclones, and those time from NOAA satellites. NOAA satellites were already there in 70s and those time frame. So this work started long back, 70s or 80s, I would say. But it took momentum in 80s when INSET was launched by India in 1982. And there were continuous series of INSET. I want to show that such coarse resolution pictures of that time, how much it results into now a very high resolution in that relative reference, and you are able to see the albedos, the infrared, thermal radiation, water vapor, and there the meteorologists use this knowledge to estimate the rainfall. The basic broad principle goes like that heavier rainfall is associated with cold cloud tops. Generally, if cloud top is cold, you will see, I mean, more rainfall. That's broad principle. Of course, there are many more things has to be go into three and this kind of estimation. And many of you must be aware of it. And there is GPM mission where global community, including ISRO, is participating into it. And in the global mission, not only visible, the thermal, the infrared, even the active radar systems are working. We call precipitation radar. They have ability even to know the vertical distribution of the cloud and rains. And you can see the daily products of this GPM mission for rainfall, and they're quite accurate except the regions of orography and those things. So this state of knowledge in rainfall results into what you call flood. They happen beyond a certain critical threshold. In 1982, a time frame, this work was done, but through visual mapping, and I saw one paper, and that was more of a visual mapping kind of work. But now, as Dr. Agrawal told, or if you see the NRSA website, Bhuvan, it is a regular product. Whenever any flood happens, you'll find that from our satellites, our SAR data or things, automatically those flood maps are created. So we have gone from the very visual mapping to this one photograph of the Ganga River. And then currently we have developed a method by which you can know this flood every day all over India. In flood, as you know, SAR provides a beautiful detailed knowledge, but passive radiometer provides a coarse knowledge, but for larger region. You can see a flood map of 780 years on the average picture, and where all the flood has occurred in the last 7 years. And this is at coarser resolution, but it gives you the broad picture. Is all data products are available in Vedas. Those who are interested can go and see the data sets. They are near real time, as well as they have a climatology and old data sets also available there. I was talking about SAR provides regular information, so it has become a quite mature and useful application. Yes, flood forecasting is a important job. Still, forecasting and data is not easy, and a lot of work are going on. NESIC is also doing in flu form, and ISG is also working at the Godavari, and we are also working on client. Here, the challenge is only satellites can give you forecast. You have to have a model, and the satellite data has to ingest into the model. We are working on it, and a working forecasting inundation model exists in this Vedas portal. You can see, but there is more specific to the Brahmaputra region. Retrieval of water level, as envisaged by 1969, now it has come to a stage level where around 100 locations in country, you can see a record of last 10 to 20 years, around 20 years record you can see from 2008 onwards, or we are working on 2002 onwards, and we will be getting this continuous distribution. This one example how Ganga, Brahmaputra in this river, and you can see on many reservoirs too. So the technology has come to this level. There's a new technology of LIDAR, what we call ISRS mission 1 and 2. They have much better spatial resolution. So that is also going to change this particular gamut of water. And particularly LIDAR has advantage, they are able to penetrate in the clean water. So you can find the bathymetry also. So people at SAC are also working, and they use LIDAR and the conventional multispectral satellite data and create bathymetry wherever is possible from the clean water. Groundwater, as everybody knows, has been a success story from ISRO in 80s time frame in form of the Rajiv Gandhi National Drinking Water Mission, and most of the whole country was mapped into different groundwater potential maps, and that's where it started. And but that the map has a limitation that it was static. You can only know the potential map, but then the demand is have a dynamic knowledge. And this dynamic knowledge only can come when you have a dynamic measurement of those things. Groundwater being not on surface, difficult to sense through electromagnetic radiation, there the concept of gravity recovery comes. I mean, the GRACE concept comes, where you don't have to send the radiation on the ground, beneath the ground, but see the effect of gravity on satellite. So there are two satellites, in a what you call together in information flying, and based on the changing in their orbit geometries and velocity, one is able to know the amount of mass which is perturbing their orbits, and by solving various mathematics and the other features of geology and those things, one can able to know groundwater. This present example shows done by our team, by Dr. Sharat Chandra, that he sees that there is a groundwater change, depletion in northern India, and somewhere they are recharged. These things were known earlier, but currently he's found, yesterday he presented that the rate of recharge is changing and slightly improving due to what we call policy implementation. Next level challenge in this line is predicting it, forecasting it through machine learning. So current observations or some modeling activity in Salil program and ISRO, and there they try even to forecast or to estimate the changing groundwater level using machine learning. This is one such example. Such work has to go further. This is the most challenging area. In the new technology, interferometric SAR also provides a knowledge of wherever the ground depletion is taking place. The surface gets deformed, and you can see those deformations in changes in surface elevation through interferometry. This is another area of importance. Water quality has been done from last 2 to 3 decades, but currently with better resolution radiometry and better systems, it is gaining momentum. And I hope in future, nationwide water quality map would be available. Although still it is the people are in working stage. Case studies exist in this line. One such example of Everest airborne sensor was there, where one flown the Everest hyperspectral spectrometer in Chilka, and all mathematics and inversion were tried out. So principles are known, methods are known. Only such measurements or satellites have to be developed. But in future, I am hopeful and think such kind of estimation would be there for whole country. As we were talking about detection of the groundwater beneath the surface to ocean, also is around 1 to 10%. We do not know how much water goes beneath it. That's not known. We call submarine groundwater discharge. Detecting from satellite itself is a very big challenge, because whenever they go, sometimes they cool up the area or heat up the area, the water of the ocean. So one exercise we did in Oka, that we found a source where the groundwater was seeping into the ocean. And there's a national mission by MOES where they are working on this line, and approximately they are finding it that where all this water is going in the ocean. This is one such area, and I would complete my presentation by showing you one new area of hydrology, not much tried, but I see a big future in this direction. Is that we detected a enhanced forest transpiration in northeast particularly, and found this transpiration influences the onset of monsoon. This monsoon, if you anytime this transpiration is more, we found the monsoon is also triggered, and we get more rainfall. And whenever this transpiration is little, we found, so there is some correlation. This can only happen when you have an isotope knowledge of water. Generally, what to measure, we measure water is H2O. It means HHO. But if you detect HDO, that which has a deuterium element into it, not possible in a normal measurement of IMD or otherwise. So you have to have isotopic measurement. So from one satellite of called i-GEOMATICS or TES, tropospheric emission spectroscopy, the team of scientists at SAC by Dr. Rohit Pradhan and team, they worked upon it, and they found that if you see the normal seasonal behavior of water vapor and what you call specific humidity, it follows some characteristic curve. But if you see in HDO, that is a delta D, what we call, you will find that it has a different behavior, because the heavier water has changes. The distribution or the time variations are little. Picking those from satellite is a big challenge. There are ground instrumentation by which you can do, and PRL, many institutions do it. But doing from satellite is a big challenge, and in my opinion, this is the future remote sensing area where we have to work upon it. And this one case study where the team found that once you can detect this isotope, you can know the transpirational, at least qualitatively. And when they found that whenever it is high, that becomes the water vapor become enriched by those deuterium element of that water. There was more transpiration, and it was linked to the rainfall. Another very important subject in future, in my opinion, would be that what you call the atmospheric river and flood. The normal floods we can deal because they happen because of the flows up in the river and slightly heavy rainfall. But sometime you have noticed in past few years, due to change in climate, suddenly huge amount of rain takes place in a city around. It is known in cities because they then seen into form of flooding and those kind of things, like Chennai, Hyderabad, Mumbai, and those cities. So that's where the water comes out. So generally, water hydrology you do within the basin, but the rain is not governed within the basin. There's a huge advection, a huge river-like phenomena takes place, and suddenly large amount of water comes from the distance around 3,000 to 4,000 kilometers, and they condense, and they pour huge amount of rain. if we have understanding of them, probably we can forecast and we can more manage the situation better. And that is the future area of research. So one team at SAC is working on this line. Hopefully, we can understand the dynamics of it, because to understand the extreme events, this need to be done. They are the phenomena of 4 to 5, 1,000 kilometers, and they bring huge amount of water. It is also known as atmospheric river. This phenomena is more into the mid-tropics, but they do occur in the monsoon season, or even without monsoon season also. Sometimes in Northeast, this phenomena takes place many times. Huge rain comes because of the advection from long distances. So this is one direction where hydrology has to move. I conclude my presentation by visualizing that a lot of these 3-4 decades has really gone into developmental phase, and if you see from the 70s to till today, there has been huge change, but in future also it has to go through like that. And the biggest limitation is the repeatability or resolution of the satellite. Hydrology is like meteorology, where we require the high temporary visit at high spatial resolution. We are able to meet high temporary resolution in meteorology because they don't require very high spatial resolution. But in hydrology, you require both, and there comes the big challenge, even more challenge than meteorology. So in future, a dedicated constellation of hydrological satellites would be there, in my opinion. Of course, it would be from the international cooperation, and now the industry is also coming into it, but it has to be there, and I think that it would be there to resolve, just like GPS and other things. There will be many, many radars, many, many things, not one or two, to solve this kind of problems, of real problems of hydrology. Obviously, we have to improve upon methodology. In my opinion, few technologies like SWAT, where you not only measure the height, you also may have a synthetic aperture radar. You also do interferometry to know the slopes of the water flowing. It's possible if you can do. There's a concept, there's a future satellite called SWAT. So those kind of things would be there in future. Assimilate information in the distributed hydrological model is a big challenging area. How to assimilate, how to have a judicious, what you call, power of the model and the observation, because both have certain advantages and disadvantages. And then one day we have to have a real-time monitoring of these events. At the moment also in Vedas, I know this is the mobile app. You can see Dr. Shashikant has developed this kind of thing. You can see many hydrological variables on mobile itself, but it has to go further and be more user-oriented and more, output should be which is useful to the society. And this is what the basic vision in which we are working on. Thank you very much.
Thank you.
Thank you, sir, for your knowledge-filled talk on advancements in satellite hydrology. Now, I invite the Honorable Chair of this session, Dr. N.S. Dan, sir, and Co-Chair of the session, Dr. Shashikant Sharma, sir, to conduct the discussion.
Yeah, thank you very much. So with the permission of chair, first let me wrap up the session. We had 3 very good lectures by eminent personalities. First by Vinod Botle, who is expert in geoinformatics, and he is the Bhuvan man. And he told about the use of satellite data for various sustainable developments and various applications like housing for all, Pradhan Mantri, Fasal Bima Yojana, and many others, and the benefits of new geospatial policies. And also he has talked about the future technologies of digital twins, real-time solution, AI, blockchain, and so on. And Bhunidhi in the short time will be available for data dissemination. Then we had lecture by Dr. S.D. Agrawal, Director of NISEC, now looking after all Northeastern states. So he has told the potential of Northeastern states and a variety of applications of remote sensing, GIS, navigation, communication, including very good outreach facilities they have. And they have very good expertise in UAVs as well as field instruments. So they are doing a lot of applications in various vertical fields like agriculture, water resource, and so on. And now they are developing good web portals for the same. Then the third lecture was Dr. R.P. Singh, who is expertise in satellite hydrology. So he has told the importance of hydrology and shown the history of hydrology. So what is done and what remains. And he has also very nicely defined the components of water cycle and use of all types of satellite data, including scatterometer, hyperspectral, altimeter, lidar, grace, and so on. And at that end, he has also told future directions to work about forest transpiration influencing the monsoon and as well as the atmospheric floods. So we are very much thankful to all the three eminent speakers for giving these fine lectures. And now I request our chair to say a few words about it, and then we can take question answer session if time permits.
Thank you, Dr. Shashikant Sharma-ji. Am I audible, please?
Yes, sir.
So this has been a very fascinating plenary session. And I was a little anxious to see if this really relates to me when Dr. Sood and Dr. Pateria asked me to participate. But I really find myself enlightened and enriched by today's discussion. So thank you, Pateria Saab, Sood Saab, and the organizers of this i-GEOMATICS 2021. This online mode is also working perfectly well, very well organized. So my deep appreciation to the organizers. And just a few points, maybe, am I, Dr. Sharma, do I have 5 minutes?
Yeah, we can have for 1 or 2 minutes here, no issue.
Miss, I was really impressed by all the very expert speakers of the day, and particularly Dr. Botale's, towards the end of his presentation, he presented the way forward. And he gave how this can be applied in governance, and gave us an overview of reforms and deregulation process going on since the beginning of this year in the policy circles, and also gave us a view of how we could balance security and access through technologies like blockchain, and of course mentioned about the 4D kind of databases with evergreen visibility, and mentioned many other interesting applications like Bhunidhi. I'm not interested in visiting this site. So the potential of these technologies came alive in this talk, and I'm really thankful to Dr. Batale for a wonderful presentation there. And coming to Dr. Agarwal's presentation about the Northeastern region, and the way he showed how this region is important for biodiversity, for agroforestry, for water resources, and how much these space technologies can do for this region. This was really an eye-opener, and I think he's doing a great job in that region, and he has and these technologies are going to have a tremendous impact there, and they're already having actually the project after project he mentioned, and this is really I congratulate Agarwal Saab for his great presentation and the service he's doing to this region of the country. And then, of course, Dr. R.P. Singh, the leader of the research team at the Space Application Center at Ahmedabad. And hydrology, this is one of the areas with which I had to be engaging to some extent in respect of my duties as Director of Research at PAU. And he mentions how the developments today, we are much more empowered to deal with hydrology at such a scale, at a geospatial scale, and the beginnings with K.R. Ramanathan and Vikram Sarabhai, and then all the way to the present day technologies using isotopes and all that. And by the way, I was reminded of my school textbooks when I saw a picture of the Bhaskara satellite in the presentation. And this is really something I think even our Punjab Remote Sensing Center should be because water is a major concern for this region. The GRACE satellites that Dr. R.P. Singh showed in his slide, that imagery, when it came out in the international journals, that was a real, means kind of a big shock to the research and the policy community in this area. And we could see how much impact water loss. Even the gravity of the earth has been affected in this region. So this was, and I think similar other insights are available from this space technology. And this is, and then of course, Dr. R.P. Singh went into the whole water cycle. And this is the kind of thing we are looking for here in Punjab also. We want to have a total picture of the water balance in the state and in the region to be able to plan for more better judicious use of this water. So thank you, Dr. R.P. Singh, for a very fascinating hydrology related presentation. And of course, Dr. Shashikant Sharma ji for being the co-chair. And Sharma ji, now it's up to you to carry the discussion, time permitting, sir.
Yeah, we have already crossed the time, so I think we will not take any question because the next organization will be affected. So, mail in case if you have any question. So thank you very much, and we will hand over to organizers.
Thank you. Thanks everyone.
Thank you, Dr. Baez, for the good words, and we'll be keeping in touch subsequently. Yeah.
Thank you, sir. Thank you.
Dr. Sharma ji, I just would like to put one remark as Dr. Baez has mentioned. Dr. Baez, you may be knowing that PRSC is submitting GRACE-based report to the government for last 2 years.
Yes, Dr. Patel, yeah.
We are submitting our report every monsoon to the government, and all the, even PAU also, Vice Chancellor used to get this report. I don't know whether it has been reached to you or not. But here, one thing which I would like to just for a few seconds only from R.P. Singh, the comparison and accuracy assessment with respect to the IM data, because when we have done it, we found that in most of the cases, sometimes it is matching, but in few cases it is differing. So Mr. R.P. Singh can put a remark on this, is how much they have done anything on correlation with IMD data?
Yeah, I mean, Dr. Pataria, what you said is very correct. The satellite remote sensing has the advantage, but at the same time, it has a limitations too. And as you said, majority of time it matches up. But in the areas where orography or those kind of issues, satellites has limitations. So we are also working and on that line to exactly know the accuracy. So, but most of the time it matches. Nowadays, if you take the global observation of including thermal, optical, and precipitation radar data, and they are good to do hydrological modeling for large region.
Definitely, there are going to be a lot of research issues which have to be thrashed out. I understand.
Yeah, we because in this field we have to continuously evolve our research and things. And I seek your support, Dr. Bansab, because sometimes what happens when we submit something to government and things, lot of, as you must have seen latestly, when Director Agriculture has said that we cannot find the crop disease kind of things. But since we are dealing constantly working with the ISRO team, all the centers, we are equally capable and doing a lot of things, but sometimes it's happened bad because of some political reason or other things. So many studies which PRC want to do or are doing are not being recognized or not being considered in that way. But anyway, academic things is one thing, but on the professional and the practical aspects, I need person like you to help us to propagate the users of this satellite technology which we are having. We have do a lot of things and we do wonders. So your support from PAU and wherever you can influence, it is very, very good for the user community basically. So
yeah, the stubble burning data. The stubble burning data has been excellent, and that's been very helpful to the government.
Any data which PRC is submitting is excellent. I am giving you full confidence, and I am ready to go into field with anybody to cross-verify whatever we are submitting. And my colleagues from ISRO, they can also watch, because we cannot do anything which is not relevant, which is not required. So I thought to take this opportunity to bring into your notice. Thank you. So
Thank you, Dr. Pataria.
PRSC,
Thank you.
I thank you, as well as Dr. Sharma and all our eminent speakers, Dr. Bothale, Dr. Agrawal and RP Singh. They have done wonderful work, and I'm really thrilled to see the lot of things which are happening. Over to you, Dr. Sood and team.
Yeah, but areas of just 10 seconds I wanted, with your kind permission.
Please.
I just wanted to, join the tone which you have said, that in the age of collaboration, there is no difference, which collaborator is contributing 15%, who is 30%, or who is contributing 50%. So you should not discuss that when it comes to science. You have the full backing, as you can talk as if you have the you have all the resources available in this ecosystem. So that is one thing which I wanted to mention. And the more we collaborate, the more we will be able to scale up and bring synergy between the various components of study seamless, and that will really enhance our vision that we have said. So that is one thing. And second remark is, sometimes perhaps in India, in geospatial community, we are over occupied with this accuracy business. I have seen the best, highest impact papers and studies worldwide that they may have inaccuracy of 35%, 40%, but it is how you explain the uncertainty. There is a lot of inherent uncertainty that is with large number of variables. So sometimes we should see that how the uncertainties are explained rather than the digit of uncertainty. So these are the two remarks I wanted to briefly mention, with your kind permission. Thank you very much. It was always a great joy to share such words of wisdom.
Thanks. Over to you, Dr. Sood and team.
Thank you, sir. On behalf of all the participants and attendees, I can say that the session has provided us really great and useful insights. Now, I request Organizing Secretary, Dr. Sood, to felicitate Chair of the session, Dr. Navteej Singh Bains.
That's all. This is the token of love from our side. So kindly accept virtually.
Thank you. Thank you, sir.
Now, I request Dr. Sood to felicitate co-chair of the session, Dr. Shashikant Sharma ji.
Accept our token of love, sir.
Yes, thank you. Thank you very much. Thank you.
I request chair of the session, Dr. N.S. Bains, to felicitate speakers. We will start by felicitating Dr. Vinod Bothale ji. Now I request Dr. Bains to felicitate Dr. S.P. Agarwal ji. I request sir to felicitate Dr. R.P. Singh ji.
Thank you, organizers, for giving me the opportunity to share my views. Thank you.
So thank you very much, sir. Okay. Thank you, one and all, sir.
Thank you everyone for their presence. I request the presenters to join their respective sessions in their respective halls. Thank you everyone.
Okay, Dr. Jha, so welcome to this and very good morning to you and very congratulations to you, sir.
Mic is mute, sir.
Yeah. The chairman has to be mute only. Speakers only have to speak. Thank you very much.
Okay, sir. So within just 2-3 minutes, we are going to start, sir.
No, I
Then
was just joking.
meeting
Please
will
go
take
ahead.
care.
I was just joking. Please go ahead. Please go ahead.
Okay. Thank you, sir.
Good morning, sir.
Very good morning.
Good morning, sir. This is Shashikant Patel, moderator of this session.
Good morning, Patel ji.
Good morning, sir. Good
मैं
morning.
तो पहले से हाजिर हूँ. वो उर्दू में कहते हैं मुद्दे सुस्त गवाह चुस्त.
Sir, very good morning to all speakers. I think we have 2-3 speakers right now. The total list is 7 speakers in this session, sir. So very good morning and warm welcome to all speakers and my respected chair and co-chair. Sir, so I think so first of all, I would like to confirm the speaker's presence here. Yasi Singh, I think Yasi Singh is there.
Yes, sir. Present, sir.
Okay. And Shoni Bora?
Yes, present, sir.
Okay. Then Sudhanshu Raghuvanshi?
Present, sir. Hello.
Sudhanshu Raghuvanshi is there?
Yes, sir. Present, sir.
Okay. Good morning, sir. Good morning. Shuman Kumari?
Yes, sir.
Okay. Brij Mohan Bora?
Yes, sir.
Okay. Revati R?
Yes, sir.
Okay. So Shivani Kalra?
Yes, sir.
Okay, thank you all speakers. They are all punctual and I think the session is delayed by 5 minutes. So first of all, very good morning and warm welcome to all in ISG ISRS National Symposium 2021. So it is my great pleasure to introduce my chair